How do we get the scales that we use in astronomy? After all, we can't run a tape measure out to the nearest stars, let alone distant galaxies. Well, we've met some methods before, especially in the presentation on cosmology, but here's a few more notes on this topic. Short distances in astronomy are measured by the technique called parallax. This is absolutely reliable for measuring distances out to approximately a few hundred light years. After that, we have to use other methods. Parallax relies on the same principle that you'll notice if you alternately close your left and right eyes and look at an object a reasonable distance from you, say a few tens of metres, and compare it to objects very much further away. You'll notice that the nearby object appears to shift relative to the more distant objects. This is exactly how we measure parallax. We measure the locations of stars that are close to us relative to objects that are very, very much further away when the Earth is in alternate sides of the Sun. So instead of the distance between the eyes, we now have the distance between the Earth on one side of its orbit and on the other side of its orbit. Because of this baseline, the stars appear to move a very tiny amount compared to the fixed background stars. And with a little trigonometry, we can work out exactly how far those stars are away. Remember that in order for the Earth to be 6,000 years old, nothing can be further than 6,000 light years away. The Milky Way galaxy, for comparison, is approximately 15 times this in diameter, and the nearest large galaxy, the Andromeda Galaxy, or M32, is about 2.2 million light years away. To calculate distances, we use the distance ladder, where different methods are used to measure different distance ranges, and all are calibrated based on those on the rung below. Some assumptions need to be made here, but they're all reasonable assumptions and seem extremely well supported by the evidence available. The various components of the distance ladder are almost entirely built around finding standard candles, that is, a recognisable object of a known intrinsic brightness or absolute magnitude. If you can find one of these and you can measure how bright it appears to be, then, knowing how bright it actually should be, you can calculate how far away it is using very simple maths. The main standard candles used are variable stars, which are stars that vary in brightness as the name suggests. They have reliable relations between their variability and their absolute magnitude. Examples of these are Cephids and RR Lyrae type stars. Another well-used standard candle is the Type 1a supernova. This is formed by an extremely well understood process with very precise and unalterable initial conditions, which means that they're all, at least at the beginning, very similar events. Relationships can be found with the absolute brightness of a supernova and certain features of the light it emits in the early stages. Supernovae can be seen out to extremely large distances and can be used to calibrate a great number of the other distance indicators. A couple of quick creationist complaints about our very own Sun. Firstly, there is a claim that the Sun is losing mass at an astounding rate, so it couldn't have been around for very long. This is a simple case of creationists couldn't be bothered to do the math. Yes, the Sun is losing mass at around 5 million tonnes per second. That sounds like a lot, but it's no big deal. The Sun has around 2,000 million tonnes of gas. In fact, its mass loss will increase dramatically near the end of its life as it enters the red giant phase and swells up to roughly the size of Earth's current orbital radius. It can certainly keep up with its current mass loss rate for trillions of years. That won't be what kills it. Secondly, the claim that the Sun is shrinking, and hence that there's no way it could have been around for billions of years because the shrinkage is too great. Well, for a start, this is another example of Hovin dishonestly picking papers that have since been withdrawn. The paper by Dunham and collaborators was withdrawn by the authors because they realised that they were wrong. Also, and you may have noticed this, it was published in 1979. All recent papers say that there is no such shrinkage. And if the Sun shrinks, it's not a great issue. The Sun isn't a solid, static object in the sky, it's a dynamic, ever-changing ball of gas. There's no problems whatsoever with slight changes in radius over the years. Some scientists believe there might be a very slow, perhaps 80-year period oscillation in the outer layers. After all, stellar models show us that the Sun will eventually grow to the size of a red supergiant before shrinking back down again, re-expanding, re-shrinking several times before it finally settles down, very probably as a white dwarf. So there's nothing whatsoever to worry about in either of these studies. In fact, these are exactly the kind of complaints that you really hope that your creationist opponents pick. In the early years of its life, our Sun would have been noticeably fainter than it is now, and some creationists claim that this is a problem. For example, if there's roughly a quarter less solar energy flux on Earth, which is exactly what our solar evolution models predict, then that would have caused a drop of 7% in the temperature of the Earth, which corresponds to about 20 degrees Celsius colder. Now this is a lot, but it's not a huge problem. For example, some oceans on Earth are 25 to 30 degrees Celsius all year round, so they would still be above freezing. Also, the greenhouse effect, that is, large amounts of carbon dioxide in the atmosphere, would counter this, and we know that the amount of carbon dioxide in the atmosphere was very much greater at certain points in the history of the Earth. Also, it's quite likely that life on Earth actually arose deep in the oceans, around volcanic areas known as mid-oceanic ridges. This is a new theory, but it's got quite a lot going for it, because the water venting from these volcanic areas at the bottom of the ocean would have been extremely hot. In fact, when we look at these areas in the middle of our oceans today, they are positively teeming with life. So life may have begun at these deep sea vents, in which case, of course, the solar energy is irrelevant because all the energy comes from the volcanism deep within the Earth. The solar neutrino problem is a really fascinating problem that's only been solved in the last decade or so. Now, the creationist claim, of course, was that we saw a problem and therefore that our models were wrong. Now, this is an example of the difference in the attitude of creationists and scientists. The creationists see a problem and they immediately assume that everything about science is wrong and therefore their book is right, whereas a scientist sees a problem and investigates it. And the solar neutrino problem is a wonderful example of this. Neutrinos are tiny, almost massless particles, which are very similar to electrons but without a charge, and they're produced in very well understood reactions in the Sun and ejected out into space. The main problem with neutrinos is that they're very, very difficult to detect because they almost don't interact with matter at all. So in order to detect them, we've had to create enormous underground observatories. And I say observatories, but really what they are is enormous tanks of water. If a neutrino happens, by some incredible stroke of luck, to interact with the water molecules, then it can produce radiation that is much more easily measured by detectors which surround the tank. There are several of these detectors worldwide, the most well known being the Super Kamiokande detector in Japan. Neutrinos come in three different flavours: the electron neutrino, which is the one produced in the Sun, also muon neutrinos and tau neutrinos. The detectors detect electron neutrinos. The solar neutrino problem was simply that the models predicted roughly 3 times more neutrinos than we actually observed. The resolution to this was very simple, that actually it turns out neutrinos change type as they're flying through space, so that 2/3 of the electron neutrinos become tau neutrinos or muon neutrinos on the way, and hence we don't detect them. So this problem has been totally resolved since 2001. If a creationist brings up this argument, then it just shows that they're not doing their research properly, and you should highlight that. Globular clusters, as we've met, are very large associations of stars, usually a few thousand, but up to hundreds of thousands, and in one case in our galaxy, over 1 million. If you look at the velocities of stars in these clusters, some of them appear to be moving quickly out of the globular cluster, and therefore the clusters can't be billions of years old that science claims, can they? This one's a doddle. Stars are held in globular clusters by gravity, of course. Occasionally a few might be ejected due to tidal interactions when stars get very close together, but in general they stay bound together. Simple physics, maths and computer models and observations all show that this is the case. Stars appear to be moving out of the cluster, but of course if you watch for long enough they'll be dragged back in due to gravity. Models are very well established beyond any doubt to show exactly how this happens, and you can just work it out with pen and paper and a bit of simple maths. This one is great for exposing creationist ignorance in a showy way. Imagine what happens if you throw an object like a pencil up in the air. If you measured its velocity as it was moving upwards, you could extrapolate that single measurement and presume that the pencil would continue upwards until it hit the ceiling or just kept going into space. Of course, this is absurd. The reason why creationists bring up this issue is simply that they haven't thought through it. Are there too many stars in the universe? A quick calculation shows that there are around 10 to the 20 stars in the universe. That's 100 million stars, give or take a few. That's an awful lot, and if you divide that by the age of the universe, you work out that, assuming a constant rate of star formation, there's 15 million stars per minute being formed somewhere. Here's the crux of the creationist problem with astronomy. They're trying to understand it using intuition. This does sound like an enormous number, and of course it is, but space is far more enormous. Again, for creationists to convince anyone that this is a problem, they would have to explain why this number is too large. It seems like a lot, but it really isn't. 100,000 stars can be formed in a globular cluster in a few million years or so, and imagine how many of those there are in the universe. There's hundreds around our galaxy alone. Most of creationism is simply a masterclass in the application of human intuition to subjects where intuition is woefully inadequate. That's why we have science, to actually work out the numbers, to do the measurements, and to show us the truth that is so often staggeringly impressive. So, we're finally finished. This was a bit of a marathon presentation, and congratulations for making it to the end. Next time we'll be looking at planetary science. As ever, there's loads more information on my website, frame.net, where you can also find a transcript of this talk and all the following ones and all the previous ones. And you can keep up to date with my blog as well as learning about some of my other work. See you next time.